Is it really tough to solve problems in physics? And most of the students thinks that some extra intelligence is needed to solve the problems. But the reality is the problem solving in physics is interesting. They are really interesting if you know the concepts in depth. And here we are going to discuss not the concepts but some easy techniques and tricks to solve some complicated level of problems. They are most commonly asked in all India level entrance exams. A body of mass m move with a velocity u and it collide with another body of mass 4m. It's a collision. The body of mass m moving with a velocity u collide with another body of mass 4m. The body is initially at rest, and after the collision what happens? The colliding body returned back with some velocity that we don't know what is that velocity. Even we can find it out by using law of conservation of momentum. And here the problem is you have to find out the coefficient of restitution, the value of E. The question is you have to find out the value of coefficient of restitution, and you can do it by applying law of conservation of momentum here. But there is a simple technique to find out the value of coefficient of restitution even without applying law of conservation of momentum. I will explain the problem once more. The body of mass m moving with the velocity u collide with another body of mass 4m, and the colliding body returned back with some velocity that we don't know, but the second body remained at rest. And in this problem you have to find out the value of coefficient of restitution even without you applying law of conservation of momentum or Newton's second law or any other equation. We can find out coefficient of restitution by a simple technique. I am going to reveal that technique. The coefficient of restitution is equal to, this is a shortcut, mass of the colliding body divided by mass of the remainder. Means mass of the colliding body divided by mass of the target body. Target body has mass 4m and the colliding body has mass m. Cancelling out you will get 1 by 4 and 1 by 4 equal to 0.25. This is a simple technique to find out the coefficient of restitution even without applying law of conservation of momentum. The coefficient of restitution in this case is mass of the colliding body divided by mass of the target body. Look at the figure. This is an equilateral triangle and there are three charges placed at the vertices of the equilateral triangle. One is plus 2 microcoulomb, second one is minus 7 microcoulomb, and third one is plus 5 microcoulomb. Three charges placed at the vertices of an equilateral triangle, and we have to find out the electrostatic potential at the center. How to find out the electrostatic potential at the center? The problem is you have to find out the electrostatic potential at the center, and there is a simple technique, and the charges at the vertices of the triangle are plus 2, minus 7 and plus 5. Add up all these charges. Plus 2 plus minus 7 minus 5. Minus 5 plus 5 0. The sum of the charges placed at the vertices of the triangle is 0. So the potential at the center is also 0. That's a simple technique to find out the electrostatic potential at the center when a number of charges are placed at the vertices of any regular polygon. You can apply the same technique no matter whether it's an equilateral triangle or a square or a regular hexagon, anything it may be. Let us discuss a problem in laws of motion, and this is an APMT previous year question. A body of mass m is placed on an inclined plane, and to prevent the body from sliding down the plane, a force F is needed. That means if the force is withdrawn, the body will slide down the plane. Here a force F is needed to prevent the body from sliding down the plane, but applying the same force, it is not possible for you to push the body up the plane. To push the body up the plane, you may need some more force. Let us take the force 2F is needed to push the body up the plane. Okay, I repeat. By applying a force F, you can stop the body from sliding down the plane. But to push the body up the plane, you have to apply the force 2F. And this is a previous year question. And here, we have to find out the value of coefficient of friction between the body and the plane. It is denoted by mu, and you have to find out the coefficient of friction. Normally solving the problem, it needs some steps, solving some equations, but I am going to tell you a secret. I am going to tell you a simple technique to find out the value of coefficient of friction without solving much complicated type of equations. And just listen it. Initially the force F is needed to stop the body from sliding down the plane, and then the force 2F is needed to push the body up the plane. So let us take 2 as N. Let us take N equal to 2, and there is a shortcut to find out the value of mu, that is N minus 1 by N plus 1 into tan theta. Here the value of N is 2, so this is mu equal to 2 minus 1 divided by 2 plus 1 into tan theta. 2 minus 1 is 1, 2 plus 1 is 3, so you get 1 by 3 tan theta. So now let us discuss another situation. A force F is needed to stop the body from sliding down, and a force 3F is needed to push the body up the plane. Now the value of N equal to 3. So N minus 1 by N plus 1 means 3 minus 1 by 3 plus 1, that is you get mu equal to 1 by 2 tan theta.